Welcome children. Today we are in the ICT class grade 6 and computer languages chapter session 2, second generation computer languages. Okay, so today we are going to see about how a second generation language is going to be mapped to the second generation computers. As we already saw, the language is more specific to the generation of computers that is being done. Alright, so let's come here to see about a second generation computers. The second generation computers were as huge as you see. Okay, they were not as big as the first generation computers. It was like compact than them. But still, we had a panel of input slots. What are these input slots? These places are nothing like plug-in places where you would have the people inputting their data. For example, I want to know an answer for a problem. Imagine I'm going to ask the computer what is 2 plus 3. That's my question. What will I do? I write it on something, okay, and plug it in here, so that the computer analyzes it and gives back the result to me. Alright, so this is how a second generation computer works. Alright, so then why do you have such a huge computer? Because there are multiple slots. It's not just one problem that you give it to them. You can give them multiple problems. For example, 2 plus 3 into 5 divided by 2. Like that, you can give an extensive expression to the computer for it to solve. That's the reason you have multiple input slots. Can you see here as well? You have multiple input slots for the second generation computers. These were the final version, a fine-tuned version of the first generation computers. Alright? Okay, so when were they launched? Let's see. They were launched in 1959 when the first generation's computers were stopped. Then it started with the second generation computers. So we were using it till 1963. Alright. So it was a way back time, not now. So this second generation computers had input slots and they were the more final version of the first generation computers. Yes. How did they work? They worked on transistors. These transistors will take the input from the user or the person sitting in front of the computer. We spoke about inputting, putting a particular data into the slot. So when the data is inserted into the slot, what will happen? This transistor will get the data from the person and transmit it to the computer. You understand? So with that transistor, it will calculate the expression that you have given and then give back the answer to us. Okay, so how do we give that instruction? How do we plug that instruction in? That we use is magnetic discs. Have you seen something like this, children? They actually are storage devices, okay? They would have magnetic films around them and there be, can you see a sharp end reader here? This is called as a reader. The data will be written here and this reader will read the data by going in circles. These are magnetic discs, okay? And that works on the principle of magnetism. Have you seen a magnet that attracts? Yes, it works on that. So when you use a film reader here, it starts reading around like this, the coil like this. Magnetic discs were storage devices which will store our expressions, and when it starts reading, the reader on the magnetic disc will be able to read through the instructions like this in a circular format, okay? And there were things called as magnetic cores. What were these? They were also depending on magnets and also a storage device. So already we have seen a computer itself means it has to store something. So whatever I give it, an expression or a problem, it has to store it somewhere and then process it and then give it back to us, correct? Yes. So when we wanted to store something, we would need storage devices. So in second generation computers, what are those storage devices? They are magnetic disks and magnetic cores. Okay, so how much would you expect them to be? They would be around just 1 MB of data. Okay, magnetic disks and magnetic cores will have less than 1 MB of data storage space. Alright, so right now what we use? We use more than 32 GB, 64 GB, 1 TB spaces and all. But they were very small because the input instructions given to them were also with less memory. They didn't have long codes, long programs to be given as input. It was just simple instructions given to them. Alright, so we saw binary numbers were used in first generation language, but there's something different in second generation language. We wanted it to make it more readable for human beings. Alright, we'll see what it has. The second generation language is a programming language associated with assembly languages. What do you mean by assembly? You mean by you have some gathering around, you call them assembly. The gathering which is arranged properly is called as assembly. Same way, instructions, those are simplified. Simplified means very low level instructions. Those are assembled in an order, in a sequence, is called as an assembly language. So that was done in the second generation language. What did they have? They had simplified instructions, first thing. Second thing, the simplified instructions were assembled in an order. So they were called as assembly languages. So the first version was either called as the 2GL, the second generation language, or assembly languages. Okay? Yes. So programs are written symbolically. What do you mean by symbolically? It means either short form or representing it in an image format. For example, I am asking you to add 4 plus 3. How would you say that to another person? You would say, please add 4 and 3. Am I right? Yes. When I'm going to talk to the computer, a second generation computer, I will also instruct them like this. Like add 4, 3. Is this the word that we are using or is it the operation word? No. You call this operation as either addition or sum of numbers. Am I right? Yes. Because usually you call them as sum or you call them as addition of numbers. Am I correct? Yes. But why are we using this add? Because everybody knows that ADD means you're supposed to add these two numbers, perform addition on these numbers. Correct? Yes. This part is called as symbolic representation. When you have a short form or an image or instead of a word, you call them as symbolic representation. So our second generation language will have symbols or representations like this. For example, if it is going to be subtraction, what will be that? I would use SUB and tell the two numbers 5, 6. This is how we would instruct the computer for a second generation language. Is that clear? Yes. So these form of representing symbolical words are called as mnemonics. What do you call them as? Mnemonics. MNEMONICS. Okay. These languages are also called as assembly languages and also mnemonics form of representation. Alright. Yes, mnemonics, that's what we saw right now. Addition, add, subtract, multiply. Can human being understand all these words? Yes, we can very well understand. And the computer will understand this in an assembled format. Okay? So that's why they're called as assembly language. Okay. Second thing, are they understood by humans? Yes, they are very much understood by humans because we use these words regularly. Yes or no? Yes. Okay. Are they simple instructions? Yes, they are simple instructions. And these instructions are easier for us as well as the computer to take on. Yes. Needs an assembler. What is an assembler? Okay, add, this is ADD, SUB, MUL is easier for us. And we also said it's going to be easier for the computer. How are we going to make the computer understand? All that the computer understands are zeros and ones. Will they be able to understand this? No. So that's the reason we use something called as an assembler. Let's see what is that. Okay. An assembler is just like a translator. For example, you have a Russian guy coming and standing. Okay. And all you know is English and Hindi, and the Russian doesn't know English and Hindi. How will you both communicate? You would need a third person who knows both Russian and English for him to communicate whatever the Russian is talking to us, correct? So that's how we have an assembler in between me or the human being and the computer. So whatever instructions that I am giving in assembly language, like add, subtract, multiply, the assembler sitting in between me and the computer will convert this into a sequence of machine language, the assembly language that we are talking about, 0, 1, 0, 1. If I say add, it will correspondingly convert it to 0, 1, 0, 1 and then send it to the computer such that computer understands. So an assembler is a translator that will convert this particular instruction into zeros and ones. You understand? Because the computer understands only binary instructions. It doesn't understand this AB, add, subtract, multiply. It is made for us to make it easier to code a program or write it. Instead of you toggling switches for adding it, subtracting it, we made it a finer version by having a translator in between us and the computer. Okay, the assembler is a translator that converts second generation language. Children, this is very specific to the second generation only, because the second generation computers are the only computers which use an assembly language or mnemonics like this. Okay, so assembler is something which you can use only for converting a second generation language to a machine language. Alright, so second generation language or an assembly language to the machine language. Is that clear? So that's why we have a translator to make our work and the computer's work easier. Okay, so what did we learn today? The first point is we saw about the generation of computers, language of the generation, and also a translator that was necessary to make the language easier for both us and the computers. And in the next session, we are going to see about the third generation language. And thank you for watching the session.